gentlemen, I'll start, even though we are not fully here yet, but I think we'll get there. First, welcome back to the Green Building 2024 conference, where we focus on a path to a sustainable future. What helps us, or should help us, to achieve that is data. We have loads of them, but often do not use them the right way. But if we would, how would that help us? Let's learn from a lady with extensive experience in developing sustainability frameworks for the European Commission and other organizations. She helps clients worldwide make their buildings more sustainable, focusing on decarbonization and resource efficiency. She's also an ambassador for Building Life's Decarbonization Initiative and a member of organizations like Cunha and the Smart Building Alliance. So, welcome Anna Cunha, the Strategic Sustainability Advisory and CSR Director at Dearns Group. Welcome, Anna.
Hello. Good morning, good afternoon. It's a pleasure to be back here to Czech Republic to talk about evolving concepts of sustainability, showcased by some of the buildings of Dearns, and talk a little bit about how these concepts have been evolving from green building to decarbonized, ESG-compliant, data-enabled kind of buildings. And actually, before jumping into that, because I will showcase it with some buildings of Dearns. Most people know our buildings, but they don't know Dearns. So actually, I give a quick intro in a nutshell. So Dearns is an engineering and consultancy firm born in the Netherlands in 1928. In the meantime, we've developed for different countries in Europe and outside Europe to design buildings on different market segments. Today, we are more than 600 engineers and consultants with offices in 9 countries. And from these 9 countries, we've been designing buildings in 60 countries in different market segments. It means that by designing buildings in data centers, laboratories, electronics, life sciences, healthcare, hospitals and airports, and real estate, which is basically everything that doesn't go in the other categories, we've been exchanging about solutions and innovations that sometimes are used in some market segments, but actually can be very useful or innovative for others. So they are not at all an innovation there, but they are really an innovation in another market segment. So it's the interest of cross-sharing knowledge in between, even within our teams. Today I'll focus on real estate with examples of our real estate market, because we've been working a lot in terms of sustainability in there, or for longer actually in the other market segments, in the other industries, on whole life carbon, on the smart aspects, and with more than 7,000 real estate projects in 45 countries. We heard a lot about ESG, about an European context that has been evolving quite fast. So we have regulation, EU taxonomy, CSRD, Green Deal, SDFR. We get lost in the acronyms, although they're all connected, and they have a sense and aim behind all that, and also associating not only new frameworks, new obligations, but also target performance goals in terms of decarbonization for Europe wide. So when starting preparing this presentation, I thought, okay, I was here a long time ago, one of the first Congress of the Czech Green Building Council, and by then I had come to talk about green building, about certification, about HQE, LEED, BREEAM, and all the multiple frameworks or certification schemes, and what was happening by then actually on Dearns side. At that time, we were designing Bosco Verticale. How many of you know this building or saw it in brochures? It became an icon of sustainability, of biodiversity. Well, we were the engineering behind the design of this building. And actually, by then, it became an icon of sustainability. And sustainability, we were saying green building, certification schemes, because it was the framework that were giving guidance on some of the themes and topics. So Bosco Verticale is a residential project, 2 towers, in Milan, Italy, 40,000 square meters, 27 floors. And it was designed and built between 2007 and 2014. One of the main features, it became an icon of reforestation through a building in a city, in an urban area. It is composed of 900 trees, 2,000 plants that keep evolving and green all along the year. So actually with a specific irrigation scheme with different plants, and therefore with specific systems that work based on the real-time meteorology. Let's jump into Bosco Verticale features, because most of us know actually a building with trees, but don't know what's inside and what were the main features that made it so known, or that keep that system alive. So the ambition of the client was by then already to have a net zero carbon, or kind of net zero carbon approach for HVAC systems, integrate renewables already by then, have a sustainable water management, because trees do use a lot of water. And actually, Durance was in charge of the sustainability and an energy strategy, MEP engineering, mechanical, electrical, plumbing, acoustics, vertical transportation, and the building physics of the building. One of the key features was indeed certification, but today I'll focus on the part of energy, the connected energy strategy, rely on geothermal and solar, and also how these benefited the strategy in terms of biodiversity and the trees that you see in the facade. I won't drown you with a lot of technical information, but just to give an idea, the buildings don't work alone, actually. They are connected within the urban district to other buildings, so another office building that you see here, mid-rise office building, and two other low-rise residential buildings. So this is the two towers, Bosco Verticale. When starting to develop these, we didn't do a system per building. So there was already a connected approach, thinking an urban scale, even for one building. So it was decided to think of synergies, to have different buildings with different uses connect to each other and have a centralized energy center that could benefit of the resources of some and use it. Reuse, resource reuse, already by then with heat. So there is this combined energy center that allowed already to minimize the number of systems, less carbon, less cost. But also optimize, by optimizing the sustainability piece, create value, because when you had in Italy, in Milan, a certain level of sustainability, you can have an extra allowance of 5% more available area. So you create a business case there too. Without diving the details, so this makes use of a groundwater system, of aquifer, that actually will supply the energy center. Basically, you have an aquifer, you go get water at 15 degrees, where the temperature of the water is more stable than the air outside. You use it to cool down the building, to heat the building, because the water is hotter than the air outside. And then it goes back through the heat exchange to a processed water collection tank, so a tank that collects it back and then sends it to the discharge holes. That's in winter, so you can heat the building with this geothermal. On summer, actually, as the water is colder than the air outside, you cool the building, you bring to the collection tank, it cools down, and then it goes to the discharge holes. Geothermal approach. It didn't serve only for the energy piece, or not only for the strategy linked to reducing the demand of the building, reducing the demand and reducing the energy from outside needed, but also by creating a connection between buildings, a synergy system. The heat from the offices could be reused to heat the water and heat the space, domestic water, and heat the space in Bosco Verticale and the other residential buildings. This during winter. And the other way around, actually during summer, when you cool down, the equipment you use to cool, to generate the cooling, also gets hot. So you recover that heat and you send it back also to the residential buildings, from the office to the residential buildings, to keep heating the hot water and for other users, and also reduce the energy need to do it from scratch. So this is just an example that by then, 2007, we were already integrating the building, the reasoning of resource use and minimize demand, and think of the opportunities in the site. It's a building, 900 trees, 2,000 plants, you need to irrigate. So there was also strategy of water management, because the processed water tanks that you saw, it's non-potable water, was thought to serve the energy center, but also to create the tanks and the water to be used as irrigation of the building. So actually, it's quite a sustainable approach to use water to keep the trees and the green alive without making use of potable water that can be used in other opportunities. So the landscape irrigation was there in terms of strategy, also connected to the whole energy, and we had to thought this as a whole system, not just for one topic, one thing, but sustainability as a whole. And here we have Bosco Verticale, thought in very early stage, because actually if you think this too late, if you think traditional processes where you design and then all the systems you put at the end with the space or with the remaining budget, well, it doesn't allow you for much, or at least to become an icon. So actually this had to be thought since the beginning to explore the potential of the energy sources available on site. And keep this in mind because we'll come back there at the end. The potential available on site and not just imagining that the energy will arrive. So the team had analyzed spaces like an auditorium of an old church, a flooded service tunnel nearby, a flooded garage also there, a flooded central plant, and what could be used to store that central energy center that could serve multiple buildings and make the exchange. So analyses were done very early in the process, in the stage. The implications of such possible solutions were analyzed in terms of cost, in terms of technical consequences, in order to be able to make an optimized design solution and caring for the performance outcome, but also of the cost and the value generated at the end. So I won't dive in the very small Excel sheet that you see there, but just to give you an example of what's behind all the trees in the facade and the strategy that was thought very early in the process. Another building from Deuns, The Edge, headquarters of Deloitte in Amsterdam. And here we shift. So the sustainability concept, green certified, evolved also with The Edge to integrate considerations of user experience, smart building, and ZEB, nearly zero energy building. What does Edge have of so special? Well, Edge hosts Deloitte. It's 40,000 square meters building, where the request was, we want this to be the most sustainable building worldwide. The request is not to be smart, actually. The request is to be the most sustainable building there. We want to be an icon of sustainability. And actually, during the process of doing it very sustainable and thinking how to make it smartly operational, it became also a smart building icon. Deuns was in charge of sustainability and energy strategy, as well as the MEP and all the systems design. Edge produces more energy than it uses. And actually, one innovative point was the use functionality, the intensity of use, because it was required to make a building to host a number of users for a 40,000 square meters building, but to be able to host the equivalent of people that would go in 100,000 square meters because they want to centralize all the people there and intensify the use. So the smart building strategy came also to intensify the use and they allow for functionalities that would make the office quite tailored to the number of users and type of use they would like to have. So there are different strategies in terms of sustainability, the atrium that works like a lungs, that also raises issues. Works very well in the Netherlands, but in other countries it will raise issues of fire security or not, so also the teams have to work on that. Reduced facade, maximum daylight, controlled CO2, indoor air quality considerations, and one of the elements that differentiates the ATES, aquitothermal energy storage, a solution we use a lot within Deuns for hospitals, data centers, labs, and here for offices, and that we've applied in dozens of buildings, but once again, an innovation in one country or in a segment may actually not be an innovation in another market, and the other way around. What's ATES? Aquitothermal energy storage. It's also a form of geothermal energy, not the one you see with the water that floods on the ground. Actually, you create the battery on the ground. You'll have a pool where you'll always put heat there, the hot in there, and you have another one where you'll always put or get the cold from there. And it doesn't circulate. So you create the battery that becomes operational and actually serves to feed the building with heat and with cold. Then it's connected to climate ceilings, but here it was just to know that, once again, we use the potential of the site, of the soil, to think how we could minimize, of course, through the building design, the demand, but actually use alternative energy resources with what we have on site. It's important to think very early in stage because the Edge was the building who reached the highest score on BREEAM, BREEAM Outstanding. The earliest you think it, the best you can in brick and play with the credits and get the highest score. If you do it at the end, you have less possibility to actually achieve certain ratings. So also the team worked to achieve the sustainability piece, but also see broadly how by making one or another choice, you could get extra BREEAM credits that allowed actually the building to achieve the rating it got. One of the differentiating aspects, but for us also as engineering for DINS, that's where we started. We're an engineering firm, MEP, and sustainability. That's where we started our smart building journey, integrating it actually in our designs. Because the Edge linked sustainability and building intelligence. So it went to other topics. Of course, we had bioclimatic design. We have solar energy for the electricity, production for the different uses. We use also production done in the neighbor buildings, so also these synergies between buildings and explore the potential and with the new legal and contractual considerations. Geothermal, the system I told you about for heating and cooling. And the smart functionality. Actually, the building works like a phone. I would show my phone, but I broke it. But actually, you see the phone, you have an intelligence inside your building operating system or Android, and actually can put the apps you want to adapt it to your user. The goal is to have a building that works like a phone and can put the apps or functionalities inside without having to change the phone, but being able to tailor it for your user. So that was the goal. But it was not just a gadget. It was not just making, oh, it's super high-tech building. No, the goal was actually to optimize the resource consumption, to allow for functionality for use intensity, and also to monitor exactly what happens into the building. How the building is being, what spaces are being used, what's the energy consumption, what do the tenants want, and how can I come with new services and therefore new business models. This is an example of what was put into the Edge. So actually you have sensors that we already have in the buildings today, just that usually they don't talk to each other. Here the system was thought so that the sensors and all the systems talk to each other, and they sense what happens inside: temperature, light, sound, intensity, presence, CO2. They connect to the systems. They have a process of beacon, positioning, asset tracking. Everything is connected, sends the info to a brain in the building. These are just giving the example of, it can be any other system, but it's just the example of the Edge. A building operating system, and actually then you can connect functionalities, apps, or develop yourself or get outside for employee or for user experience, whatever they want. They were able to connect elements for facility management, for predictive maintenance, smart cleaning, and other smart features, and asset tracking, and for real estate managers, the owners, to know exactly what happens in there, to think of new elements, increase the property value, and work on the building analytics, knowing how the building performs. We know how many of you today are being asked to decarbonize, to send your performance result, but how are you challenging to get the data? Well, this was thought to, let's optimize the building, make it sustainable, but getting ready to talk and getting ready to report. So it was also a shift point for us in terms of engineering. Here is the example. Actually, there are many other solutions inside, but I'll be focusing on this differentiating point. The building was thought to be like a mobile, where you can make it progress, you can evolve in terms of functionality without having to change the building and the systems inside every time a tenant would change. And of course, once you have systems that work for something, if you think it along very early in the process, you can connect other elements. And that's where actually we started working with the client to understand their expectations, the experience they want to have inside, and how they can have systems that allow for this experience within the building. This is an example from that is allowed also in the Edge, but that we did when we did a project of Microsoft in Amsterdam to their headquarters. An example of what is done in the Edge, the systems talk to each other, the system connects, the system gets the data and converts it into dashboards that allows you to have data-driven decision-making and really act on the building, taking decisions with elements actually that allow you to understand what is happening inside, and actually propose it as a service for your tenants that are aiming to get this info about their occupation. Another building, Maison Île de France. Now we travel to Paris, but I'll be going tomorrow. Another challenge. In this one, we integrated everything this before, but also the aspects of well-being, health and well-being. zero carbon, because zero energy is different from zero carbon. Zero carbon consideration since the early stage. In this case, the client. This is a student's residence, so a house with 142 rooms in Paris. Students design all the energy sustainability strategy and the MEP engineering, once again, with an architect where I start saying actually that the net zero carbon goal was here from the beginning. The client didn't want to use nuclear. They wanted the building to produce its all energy needed, and they wanted it to become an icon in terms of exemplarity for the market. This building was designed when the RT 2005, so thermal regulation in France 2005, was in place, so that those were the levels we had to comply. It respects today the future regulation of positive energy buildings today. We did the tender in 2010. It finished 2017, so just to say how we anticipate, because actually given the process and how regulation is evolving now, if you don't want to be obsolete at the delivery, think ahead of what your regulation requires today. So what's the principle of this building? Well, we started thinking, first innovation, the work with the architect. It was a collaborative work since the beginning. The architect said, how do you see an energy strategy for here? What's the sustainability? We'll design the building based on that, and we worked since the beginning hand in hand. So already there is an innovation because it's not the usual practice of the market. And it is key because what we need to deliver is not pieces of building, it's a global performance. So each of us has a responsibility, and whatever we deliver will impact also the delivery of the others. So it was really a collaboration. And how does the building work? Well, we thought that the fact that it needs heating domestic for heating of the building and domestic water, and it needs electricity for lighting, ventilation, and for the small power and the other cooking and other uses. And actually, sun can provide energy for both these elements. How? That's where the team just had an idea that actually we saw in Germany and Switzerland for little houses, but here we put in a big house. So the idea was to pick a tank full of water, let's heat it with the sun, and use the water, the inertia along the year, and also produce on the roof the electricity needed. Simple. It's a tank with 15 meters, full of 150,000 liters of water. It was a first in France, because this kind of tanks are used usually in industrial buildings, horizontal, and there's another picture I don't remember, so horizontal for industrial, and underground. And here, we're using it vertical for residential and in the facade. So, and we're thinking how to integrate this in the district heating network, because actually if there was a problem in the future, also think for resilience. So here's the building. So the southern facade gives to a highway, so it was not that comfortable or pretty to see from the room. So we used the south facade for the energy production. So here's the building, and in the middle, poof, 2 tanks of water. And in front of the tanks of water, solar panels that will heat the water in the tanks. The tanks, as they are very high, higher than me, but that's not hard, vary the temperature from 50 to 90 degrees. So actually, we can pick up the temperature at the temperature we want, either for heating or hot water, in closed loop. So we don't use the water, it closes and it heats the water that is used. But actually, so this is just it's also technical challenges because we had to stop the highway just to put the tanks that day. With innovative systems, know out there what's the solutions, make the good mix to integrate and have this performance at the end. Well, I'm going the other way around. It's not just putting solutions, it's thinking the building to minimize its energy need. We needed to understand clearly how the users' behavior, so the students' residents, how they behave, minimize the use of water and energy, and heat, resource reuse, once again, heat recovery for the showers, for the ventilation network, so that we recover everything that is lost, so that we need less energy, and that we can stick to the promises. And it's a building that actually produces the whole energy it needs. It's without cooling, it's not cooled down. Oh. Here it is. And by minimizing, first it's just an example. Minimize the energy demand. This is the room. The bathroom is just behind with glass like that. The light passes by. During the day, we don't need to switch on the light most of the times, as you see in here. And so it's little things, but it will build the whole strategy of the building. And also think about automation by that. Well, it's students, they will stream, they will party, they are not very aware of sustainability. So how can we control their behavior or help them in their behavior so that the building don't get consuming a lot outside of our scenario. So actually, even the technology or the tools that were put inside were thought to make intelligent way of functioning, connected way of functioning, so that the rooms work like an hotel and that on real-time occupation, so that we always keep in mind that it's not just delivering a building that is sustainable in its fabric, it's also delivering a building that will be sustainably used and where the users know how to use it and help controlling a little bit the behaviors when they don't know. So also by then, and part of the presentation we saw today, Maison Île de France had a wide range of timber construction elements. We're thinking of the prefabrication, calculated the whole life carbon, minimizing the site waste, topics that you see today, and that were already being considered by then because we needed a whole life carbon approach and want to touch different topics. And always think not just one system or another, but the global performance approach and how the building can work fully and in terms of global performance at the end. So always put together the different solutions that give an idea, and these require complex studies. And another thing of innovating, it's a building without cooling. Not every client would accept to have a building without cooling. But actually, if you don't have cooling, you have less energy demand. But it requires making a bioclimatic design that works. So it was for us a project that worked in the energy and ecological transition, human experience. We engage the users, we engage the client. The building has a system of sound that makes a little uncomfortable sound if it's consuming more than it produces, helping the user. Digital transition, also think of the systems to talk to each other and serve the purpose of sustainability and resource efficiency, and process revolution. And if I mention the process, because these projects are not easy, they become history, but they're not easy, because this kind of modeling of innovation, first you need to declare innovation, you need to get insurance, you need to model with tools that are not in the thermal regulation of the country. So actually, it requires daring to innovate. Clients that dare, we all like to hear of innovation, but how many of you would like to be the first to try one of these systems? And put it in the, especially when we're tendering with normal procedures. Well, we need people that dare in our teams, in their teams, and explain a lot. Yeah, is it going to work? Yes. Is it going to work? Yes. It's going to work. No? Yeah. So to persuasion and education we heard today, education is a big part of the change. So we need to train our teams, we need to train the others, we need to learn, we need to push the know-how boundaries, because an innovative project is called innovation because we're doing something that is not the usual, the business as usual. Train, consult, and share. It's not, oh, that's the competitor, don't share. No, we need to talk to each other and to learn. And otherwise, we won't accelerate the process. We'll always work on silos. And in-use monitoring. It's a building that actually monitored its first use of life, and it helped a lot because we found a lot of things of construction and of use that actually helped the following scenarios and to solve issues we wouldn't have never discovered if we had not monitoring that. Triodos Bank, headquarter of the Triodos Bank, wanted to be an icon of terms of sustainability, and you see the topics we saw before, well, circular. We added circular, biodiversity, reversibility, building passports. So also, the concept keeps evolving. Durance, once again, energy and sustainability and MEP design. Complete wood structure, we heard it earlier today. Biomimicry design, to copy or imitate nature. And also, one thing that is interesting is to see that we have the net zero energy approach, but also biodiversity, biosourced materials, building passport, because the building was thought not just for today, but for its end of life. How can you make a building with a beam that you store all the information about the building, and you get it ready for the end of life? You get it reverse-able, so that it can disappear at the end of life, and that your waste becomes resources of other buildings. That is thought at this stage too, and enters into the whole life carbon approach. So it's an example, and never never forget to reduce the demand of energy. It's not just, we add technology layers and solutions. No, the goal is actually to reduce the amount of energy the building needs. So this is what's been happening, and now, and next, what's the next stages? We talked about data. And if I mention data-enabled buildings, because the goal is not to make smart, super high-tech, we need to do innovation with a purpose. And actually, data-enabled buildings. Why? Because we hear a lot about ESG. Well, ESG, with other names, has been there for a while. It's just that now it's in regulation. You have to comply. Transparency. ESG is about transparency. And transparency is about data. Data availability, data reliability, data responsibility. Who manages the data, who's in charge of actually the results. It's about compliance, because you need to comply with the goal, so with the performance. And to define that performance, you need data. So everything is connected. And that's where we see that at the end, investors and developers who've been working, ESG is just one of the levers impacting an asset or a portfolio value. It's ESG, it's data asset management, it's user experience, drag maintenance, cybersecurity, and other aspects that actually will influence the net operating income and the capital value of an asset. But have you thought that you need data? When you have your dashboards or data asset management, you need softwares and apps. And the apps need data. And the data come from the systems you have in the building. The earlier you think them to be able to provide that data, the more you can do at the end. So the goal is actually to think of the minimum infrastructure that will provide you the maximum of functionality and resilience and flexibility. And we see that because we're an engineering firm. But currently, we're designing actually the digital strategy of buildings, of portfolios, and think of the infrastructure all buildings should have for a specific client so that he can get the data at the end of what is happening in all these buildings to facilitate reporting. It's happening. And actually, you should see it from the other way around. The Edge became an icon. It became a brand, and actually it became a business. The Edge, hashtag that you know, actually uses this smart infrastructure and the data to provide full data-driven service packages to its clients. Schiphol Real Estate, Amsterdam Airport, uses the same technology and has another business model, which is smart data instead of smart service, provide infrastructure services and data, and then the tenant chooses its own applications. Red Company, same technology, another business model, where they provide infrastructure and the data-driven service activated when the tenant is in. So actually, it's how we use data, how we use the infrastructure to also influence where you position the market, how you create value. Yeah, it comes from engineering that you usually put at the end of the process. So we have here infrastructure, creates data, used by software, management, operation systems. Where we see today is that we're designing smart buildings, creating strategies in the beginning of the process to connect the data dots, you need it for reporting, to generate value, help your business, and ensure digital transition and resource optimization use. It's how actually infrastructure you have will help you generating the KPIs you need in terms of health and well-being, sustainability, optimize operations, service and user experience, and many others. And how that comes from the infrastructure you put inside. And I tell this is happening for one building, and we're working with clients that are implementing this on their portfolio all over Europe. With blueprints, same technology, same infrastructure, the building varies. But that's the purpose behind. And one other aspect, and then we won't go much further, off-grid and regenerative. Does anybody know, except those I talked before, what this is? No? This is Netherlands. Yeah, until there some of you had arrived. But what is red? Red is the regions of Netherlands where you develop a building and don't get energy before 5 to 10 years. It's quite red, the scenario. So all of you that made a decarbonization plan of your assets, thinking that actually energy is there and renewable will come, well, actually it's not there. Because actually we are facing a congestion of the power grid. This is Netherlands, it's today, and I was already talking about this 2 years ago. It didn't get. Because the pace of decarbonization being demanded by the buildings is being faster than actually the pace of evolution of the infrastructure of the cities to generate energy. Have you thought about it? Actually, we have projects that to move on, they say, okay, go ahead, technically it's okay, but we'll wait 5 to 10 years, tell it to your clients, to get energy. So actually, designing buildings today that are going to this off-grid, regenerative approach, or actually you need to think how it will generate, store, and use the energy locally without counting on what's around. Because actually the grid is saturated. It means you don't get energy, but even if you produce, you don't put the energy in. Different problems. Conceptual design, self-sufficient buildings, that's where we stand today, thinking on the solutions, on the possibilities with our clients, how you can save, manage peak shaving, local generation, and storage of energy. And actually, to store, you need a battery, or the soil, or other solutions. Remember energy storage, energy generation that we've been using in the buildings that we started telling in the beginning of the presentation? It's topics that are updated, solutions are there, just that the context was different, and the dynamic too, and the willingness, or the limitations by then. So here is just an example, exchange of heating and cooling with the Hague University to a mixed-use development in the Hague. By the way, that's your, just nearby, it's our office, if ever you want to come. Regenerative buildings and sites. It's actually pushing the thinking beyond. It's not just have regulation and I'll reduce, or I do net zero. It's going positive. How do I impact positively? How I make it better than it was before? Be it for the water, energy, how actually I can generate use and contribute for other buildings, because you know, not every building will be able to be net zero. So you need to find solutions. You need to collaborate, find new business models. We need authorities to also bring new ideas to make it much more agile for the place to play and create synergies between different types of buildings, and that requires doing differently. Connecting different market segments, airports, data centers, labs, residential that were mentioned in the beginning. So it's not just collaborating internally with our teams with endurance, it's all the market and at all the value chain. And even ourselves, we're evolving, having this parametric design. It's no longer deliver an expertise. It's defining parameters and make at the end the global performance to reach the to integrate those parameters we define. So what's next? This keeps evolving. If you're waiting it to stop, it won't. So you have ESG pressure. We heard it in the beginning. And the game is changing. Regulation is there to be adopted. And it can be quite a mess for those who are only diving on these now, but actually things are connected. So there is pressure, but not just from regulation. It comes also from the market, from institutionals, from the users and the tenants that have new demand, new requirements when they want to select a site. So when we talk about ESG to my clients, I see different type of reactions. Some panic. We're all gonna lose money. So panic emerges for some. For others, ESG can be an opportunity, a risk, let's see, let's test, I'm in doubt. And for the others, understood that it actually can be really a great opportunity and you better do before others. Because if some say ESG creates value, for others, and the market is tense in Europe, ESG will be actually a way of depreciating less than others in a context that will be tough still for a while. So ESG is becoming a license to play. It's not a trend. You won't be ESG compliant. Actually, your asset will probably won't be able to play or to operate as you planned initially. That's not me saying. That's the latest reports of VLI. And when you look at that report, what are the raising concerns from real estate players? 9 out of 10 think that running an environmentally and socially sustainable business is the most important factor for a successful organizational, I would read here, but it's too small for me, transformation within the real estate industry by 2025. 9 out of 10. Are you the 1 out of 10 or the 9 out of 10? And in those topics, the ones rising awareness from one year to another, environmental sustainability, decarbonization requirements, increased regulation, national and international. Don't think Czech, huh? Think Europe, because investors are there, are coming too. And some of you have assets outside. Asset obsolescence. You don't comply, it's obsolete, don't operate. Lose money, lose value. So if you're panicking, it's not over. This is in Brussels. In September, on the next years, companies will need to invest 3% of their revenue to finance the transition in accordance to ESG norms. Have you budgeted for next year, for this year? Yeah. And it's there to stay. And the most important thing that, not the most, but one of the important things I'd like you to note is that Colliers International, their report said, 45% of investors intend to dispose up to 20% of their portfolio in the next 5 years, where assets were deemed to be non-ESG compliant. Or engineering, we're being asked by investors at transactional stage to analyze the assets and tell decarbonizable at this cost or not. Are you the ones disposing of your not ESG, non-compliant assets, or are you being the ones buying it, thinking that you can decarbonize and at the end it will be costly or not feasible? Do you want to suffer it, or do you want to anticipate it? Do you want to take action, or just, yeah, I didn't see it coming? It's not me, it's investors saying. So actually, this works for life and for work. We suffer not from the events in our lives, but from our judgment about them. You can decide to just see it coming, to react, or to suffer it, and say, oh, what do I do now? I lost money. Or you say, oh, I actually anticipated, and every crisis is an opportunity. I am positive, because when I see how engineering has been evolving, infrastructure is not just systems that we put at the end. We think it ahead, and we think it for multiple purpose. And we're thinking it not just for one asset, but for portfolios. Investors and developers are calling engineering at early stage and corporate level, not just at the end. And that's change. I'm positive because actually it's about performance. It's about understanding the power of data and the fact that sustainable buildings can go much beyond that some topics. It's about data sources, data lakes, data monitoring, dashboards, analytics, and actually being able to decide better. We're being asked to analyze also these aspects at the portfolio, to decarbonize, establish guidelines and blueprints, to be sure to have ESG-compliant assets, but that serve also a business purpose. I'm positive because where we used to do engineering with kind of boring drawings, we're actually doing dynamic models, being information that prepare the information of all the building, and data is money. Because you prefer to buy a product with no information, or a product is quite well detailed, its features, and you know to count. In Madrid in our Congress, one of the investors said, I prefer today to buy an asset that is very low performing, but has a full set of information that allows me to understand where it goes, than a theoretically very sustainable building that I know nothing about. So yeah, information has value. And engineering is being called to understand how the building performs and its potential. I'm positive because this is an example of what investors, finance, are asking transactional process. Come, analyze the building. Tell how it behaves, and also, by the way, establish decarbonization scenarios, the interventions, what it results each scenario, group of scenario in terms of energy consumption, CO2 emissions, and the cost, the savings generated, and by the way, put it in the CREM, carbon risk real estate monitor analysis for me to understand if I select this, when does my asset become stranding? That's how building performs, and that's how we're translating technical features into decision-making information to decide what to do with those assets. I'm optimistic because when we see from the beginning how ESG can be a lot, and it can be small, it depends, but up to you to define the scope. The goal is out making fit for proposed assets. Engineering is looking to several aspects of ESG, the planet, the people, prosperity, link the three of them. And actually from guidelines to energy, carbon, water, and all the topics, we can all act on that. So to finish, remember the buildings we showed along the presentation? All of them were looking to net zero. They were using site potential, generating energy, storing at their kind, and it won't stop. So I'm optimistic, and I'd like to see you also optimistic to on board on these, and actually for the next time I come to check, to put the Czech building in there, and to see together what will be next, because this requires a lot of collaboration and it requires to go fast. So I hope to count with you for the next levels, and don't wait, because others will go faster if you just stop and see what's coming. So, Yakuye, thank you very much for your attention.
And I thank to Anna Cunha for her presentation. And I think it can't be otherwise than being optimistic when I saw that we will reach Zen.
Yeah.
The zero energy neighborhood.
And nuclear. Yeah, zero energy neighborhood, and for one of the projects they call it zero energy nuclear, but yeah, zero energy neighborhoods because that's the synergies needed, yes.
The Zen. Okay, we have 2 questions. We go very quickly. How to prevent water damage to timber buildings? Is moisture monitoring used for the structure, as you were showing the building?
Well, endurance is not the structural engineering, so I'm not the expert on that field. How do we prevent moisture? Actually, with the indoor air quality, with humidity levels, you need to, with our department actually of building physics, think of the health and well-being aspects, and also how create environments that do not degrade the health of people, but do not degrade the building itself, so that it can last and also stick to its promises. So it's elements that we enter into consideration in the modeling done
of the process. Okay. Yes. How does the decarbonization strategy of Deerns look like? Which pillars did you define as most crucial to reach the goal of climate neutrality?
So that's for my head of CSR. All right. So actually, we're taking very seriously this.
But we don't have another 40 minutes for that.
No, I'll be fast. But synthesis is not my strength. But we're working on the CSRD compliance. So integrating the CSR, Corporate Sustainability Reporting Directive. It's a compliance piece, but we use this opportunity to think our business. What could be the next level ESG strategy within Deerns, and how could we bring that to our own engineering services to review our business positioning in terms of contribution to decarbonization. So the goal is to think how we do our engineering, not just delivering expertise, as we were saying, but being able to deliver actually performance outcomes that is in link also with what was being said by John in terms of carbon result, and therefore changing how we see what to deliver at the end. This requires a lot of awareness, education of the teams, and on the other way around, we're trying to do this faster because actually our clients mainly are obliged 1 year earlier than us for the CSRD, but through their compliance, they are asking their supply chain to engage in their ESG strategy and therefore to provide proof of sustainability strategy within the firms they are deciding to engage. So actually, although we come 1 year later in terms of obligation, we'll have to be ready 1 year before if we want to be able to provide proposals that are technically interesting, financially interesting, and not discriminating in terms of ESG. So we take it very seriously by the services we develop, how we can support clients in their decarbonization, but in the materiality analysis, we are a services firm. The elements that count most, that are most material, are climate change and carbon because of our travel to projects or to congresses, and the workforce. I use a lot of train actually. I'm based in Brussels, and to Paris, Germany, London, and Netherlands is always by train. But for Czech, it would take. I wouldn't be able to do it in the agenda times. But also to the own workforce, actually, the people caring for their health and well-being, and creating conditions that human rights and other aspects that appear in the social part of the S is what weighs more as a services firm. But we can make the impact through the service we provide and how we are supporting our clients, and that it's already been done. And actually, we calculate every year the carbon emissions avoided through our projects and advisory divided by our own impact to see how many times our positive impact is higher than the negative impact of our activity.
And for the rest, you may ask Anna at the lunch break, but for that we still have some time. But for now, Anna Cunha, thank you very much.
Thank you.